All right, let's talk about the James Webb Space Telescope, because this thing is doing so much more than just taking breathtaking pictures. In just its first couple of years, the data it's sending back is starting to shake the very foundations of what we thought we knew about the universe.
And I want to dive right in with what is probably the most shocking discovery. This isn't some kind of clickbait or exaggeration. Webb is looking into the deepest, oldest parts of the cosmos, and it's finding galaxies that are so big, so bright, and so well-formed that, well, according to our best theories, they just shouldn't be there yet. This isn't about tweaking a few numbers in a model. This could rewrite the first chapter of the universe.
So, first things first, let's get a handle on what makes Webb such a powerhouse. I know it's easy to just think of it as the new Hubble, but it's not just an upgrade. It's a completely different beast, a whole new way of seeing the cosmos. I mean, just look at the stats side by side. Webb's mirror is a whopping 6.5 meters across. That gives it more than 6 times the light-gathering power of Hubble. And it sees in infrared, not visible light like our eyes or Hubble. Plus, its location is totally different. It's not whipping around the Earth, it's chilling out about 1 million miles away at a special spot called the L2 Lagrange point. This keeps it super cold and super steady, far away from the heat and glare of our planet.
So, why infrared? Why is that such a game changer? Well, it's all about something called redshift. See, as the universe expands, light from the very first galaxies gets stretched out on its long journey to us. The wavelength gets longer, shifting it from visible light into the infrared spectrum. So Webb is basically a time machine, built specifically to catch that ancient, stretched-out light. And as a bonus, infrared light can slice right through clouds of cosmic dust that would totally blind a telescope like Hubble, letting us see stars being born inside.
And here's some just fantastic news. Webb was only designed for a 10-year mission, mostly because of how much fuel it had. But the launch was so perfect, so incredibly precise, that it barely had to use any of its own fuel to get into position. The result? We're now looking at an operational lifetime of over 20 years. That is literally double the science we were hoping for. Incredible.
Okay, so let's get back to that mind-bending stuff. Webb is peering back to a time we call the cosmic dawn, just a few 100 million years after the Big Bang. And the things it's finding there are making astronomers question, well, pretty much everything.
This is it. This is the single biggest question Webb has thrown at us. Our standard model of cosmology, our main theory of the universe, it predicts a very slow, gradual buildup. Little things form first, then they merge over billions and billions of years to create the huge galaxies we see today. But Webb is finding galaxies that seem to have skipped their entire cosmic childhood and adolescence and just jumped straight to being fully grown adults. This quote from a discussion between physicists just lays out the problem perfectly. Based on their distance, how redshifted they are, these galaxies should be babies, only 500 million years old. But when we look at their light, their mass, their structure, they look like they're 10 billion years old. That is a massive contradiction. We're not talking about a small measurement error. This is a fundamental conflict with our understanding of how time and cosmic evolution work. But, and this is a really important but, here's the counterpoint you hear from many scientists. Before Webb, our models of that super early universe were based on, frankly, very little data. It was kind of like trying to draw a map of the entire world when you've only ever seen your own backyard. Webb is showing us the whole landscape for the very first time. So of course our old maps are going to need some serious revisions. This isn't a crisis. This is just the scientific method in action.
And if that wasn't weird enough for you, there's another wild idea floating around. What if some of these impossibly big, bright things aren't actually galaxies? There's a theory, a controversial one, that they could be something called dark stars. These would be hypothetical behemoths, powered not by nuclear fusion like our sun, but by dark matter particles annihilating each other in their cores. It's a long shot, but if they exist, it could solve some of these mysteries.
Okay, so from the very dawn of time, let's zoom way in to worlds much closer to home. Because Webb's other huge mission is the incredibly difficult search for atmospheres on rocky exoplanets orbiting other stars. Now, to really get why this is so hard, you have to understand something called atmospheric scale height. It's basically a measure of how puffy an atmosphere is. For a gas giant like Jupiter, the atmosphere is enormous, which makes it relatively easy to see. But for a rocky planet like Earth, the atmosphere is just this incredibly thin, fragile skin. Webb is trying to analyze the starlight that filters through that tiny little sliver of air. It's an immense technical challenge. And this quote from a couple of researchers really delivers a necessary reality check. We are pushing our technology to its absolute limit. As of right now, no one has been able to say, yes, we have 100% detected an atmosphere around a rocky exoplanet. The signals we're looking for are so faint, they often just get lost in the random noise of the data.
So what is the picture that's emerging from Webb's first looks? Well, it's pretty stark. The rocky worlds it's studied so far seem to have scorching hot day sides, which tells us there's probably not much of an atmosphere to move that heat around. The data suggests we're either looking at bare, airless rocks or planets with very, very thin atmospheres. For these specific planets, at least, the hopes of finding a thick, Venus-like atmosphere have pretty much been ruled out.
But Webb is so versatile. It's not just focused on these two big questions. At the same time, it's rewriting cosmic history. It's also confirming theories that are over a century old. And of course, finding brand new things that just make us scratch our heads. So first, the confirmation. Webb is giving us the most unbelievable views we've ever had of a phenomenon that Albert Einstein predicted way back in 1915. It's called gravitational lensing. The best way to picture this is to imagine space-time is like a big rubber sheet stretched taut. Now, you place a heavy bowling ball, that's our massive galaxy cluster in the middle. It creates a deep dip, right? Well, light from a much more distant galaxy behind it has to travel along that curve. As it does, its path gets bent and magnified. This can create these beautiful, distorted arcs of light, or, if the alignment is just perfect, a complete circle called an Einstein ring. It's nature acting as a cosmic telescope for us. But you know, for every answer Webb gives us, it seems to pose two new questions, like these things called odd radio circles, or ORCs. They're these huge ghostly rings of radio waves that might be the shock waves from some kind of galactic supereruption. Then there are the mysterious red dots. In some light, they just look like compact little points. But then Webb looks at them and reveals they're actually these big, sprawling, messy structures. We're really just starting to figure out what's going on with these. Okay, for this last part, let's bring it back down to Earth. Because behind all of these amazing images and all this mind-blowing data, there's a huge, collaborative, and incredibly competitive human effort making it all happen.
If you're an astronomer and you want to use Webb, you can't just book some time. You have to write a detailed proposal explaining what you want to do, and the competition is absolutely insane. In the most recent round, there were over 2,000 proposals submitted for only 241 slots. That's a success rate of about 1 in 9. It is, without a doubt, one of the most in-demand scientific instruments ever built.
And this isn't just one country's project. I mean, check out these numbers from the latest batch of approved projects. You've got over 4,000 scientists involved from almost 500 different universities and labs in 39 different countries. This is truly science on a global scale. It's a human endeavor. So, how are all these brilliant people actually using the telescope's precious time? This chart is so revealing. You see that? The two spectrographs, NIRSPEC and MIRI, they take up over 70% of the observing time. This tells you that Webb's primary job isn't actually taking pretty pictures. Its main job is spectroscopy, breaking light apart into its component colors to read its chemical fingerprint. That's how you figure out what things are made of, how hot they are, and how they're moving. This is where the real scientific revolution is happening.
So here we are. Webb is already pushing up against the edges of what we know, challenging some of our most fundamental ideas and uncovering puzzles we didn't even know existed. And the amazing thing is, we're just getting started. With 2 more decades of discovery stretching out in front of us, you just have to wonder, what basic, fundamental truth about our universe, about where we came from, is it going to rewrite next?